Problem 25, Quantum Mechanics. The question is, a particle is scattered by a central potential V of r equal to V0 r e raised to minus mu r, where V0 and mu are positive constants. If the momentum transfer vector q is such that the magnitude of q is much greater than mu, the scattering cross-section in the Born approximation as q tends to infinity depends on q as. So in the question, the dependence of the scattering cross-section on q is asked in the Born approximation. The particle is scattered by the central potential V of r equal to V0 r e raised to minus mu r. First, let us write the scattering amplitude f of theta, that is equal to minus 2 mu by qh bar square integral 0 to infinity r vr sin qr dr, where v of r equal to v0 r e raised to minus mu r, which is given in the question. Now we can write it as minus 2 mu by qh bar square integral 0 to infinity r v0 r e raised to minus mu r sin qr dr. To find f of theta, that is the scattering amplitude, let us substitute sin theta as e raised to I theta minus e raised to minus I theta by 2i, so that your integral will modifies to a standard form. So f of theta becomes minus 2 mu v0 by qh bar square integral 0 to infinity r square e raised to minus mu r. Then instead of sin qr, we can write e raised to iqr minus e raised to minus iqr divided by 2i. Close the bracket dr. 2 and 2 cancel. I comes in the numerator. So f of theta is equal to mu v0 I by qh bar square integral 0 to infinity r square e raised to minus mu minus iqr dr minus integral 0 to infinity r square e raised to minus mu plus iq r dr, e raised to minus mu plus iq r dr. Now to find out f of theta, we have to evaluate these two integrals. Now these two integrals are in the standard form, integral 0 to infinity x raised to m e raised to minus alpha x raised to n. So let us use that formula to evaluate the integral. Now f of theta becomes mu v0 I by qh bar square. Now within bracket, the value of the first integral is 2 by mu minus iq whole cube minus the value of the second integral is 2 by mu plus iq whole cube. Now let us take 2 outside the bracket. So f of theta become 2 mu 0 vi by qh bar square. Now within bracket we have 1 minus 1 by mu minus iq whole cube minus 1 by mu plus iq whole cube. Mu plus iq whole cube. This is the expression for the scattering amplitude f of theta. Now we have the quantity inside the bracket is in the form 1 minus x minus iy whole cube minus 1 by x plus iy whole cube. So use the result given above. We have f of theta becomes 2 mu 0 vi divided by qh bar square. We have to evaluate the quantity inside the bracket, that is minus 2i into q cube minus 3 mu square q divided by mu raised to 6 plus q raised to 6 plus 3 mu square plus 3 mu square q raised to 4 plus 3 mu raised to 4 q square. This is the result you are getting if you evaluate 1 by mu minus iq whole cube minus 1 by mu plus iq whole cube. This is the expression for f of theta. Now in the question, we have to find out what happens when q is much greater than mu. When q is very much greater than mu, our scattering amplitude f of theta, we can say it is proportional to 1 by q times q cube divided by q raised to 6. All other term will vanish because q is much greater than mu. Or we can say the scattering amplitude f of theta is proportional to q raised to minus 4. Now we have the expression for the differential scattering cross section d sigma by d omega, that is proportional to modulus of f of theta square. We have obtained f of theta, that is proportional to q raised to minus 4. Therefore, d sigma by d omega will be proportional to q raised to minus 4 whole square, or d sigma by d omega is proportional to q raised to minus 8. Therefore, from the given option, option A is the correct option.